So they gave us two one-to-one functions, g and h here. The first thing they're asking us to do is find g inverse of 0, next one h inverse of x, and a composition. So I'll do one at a time, okay? Since the first part is asking us to find g inverse of h, we're going to write an inverse of that discrete function. Okay, let's find inverse. So look, I'll do it right underneath g. We're going to write ordered pairs for g inverse. Okay, you just switch x and y. Okay, so switch -2, 4, 4. The first order pair you have is 4, -2. Switch 0 and -1, you get -1, 0. Switch 4 and 0, you get 0, 4. And that's what I'm doing to write the inverse order pairs. Switch 5 and 1, you get 1, 5. And the last one, switch 9 and 7, you get 7, 9. All right. So let me move this down, because the first part was asking for this. They were asking for, what is the function value? What's the inverse function value when the input is 0? Okay, when the input is 0. So one of them have an input of 0. Okay, where is that? Is that 0? Nope. Is that 0? Nope. Is that 0? Oh yes, we found it, we found it, we found it. So when the input is 0, the output from this inverse function is 4. That's it. That's all you do really. Just reading the output of an inverse function. So if I make up another one, what if I ask you, what is g inverse of 7? What would you say? Right there, right? When an input is 7, the output came out to be 9. Let me do another one. What is g inverse of -1? Well, I crossed it out, but it was actually the middle one right there. So let me try to get rid of this x mark. So when x is -1 in the inverse function, the y came out to be 0. So that's what they were asking you to do on that first part. Okay. Now the next one, it says go ahead and write the inverse of x. So I'll do that probably like over here. Okay. I'll copy this function and I'll do the inverse work down here. Okay. So if you want to write an inverse function, you switch that function name into y, because now we want to switch the x and y. We're going to write the x and y replaced by the other letter. So you're going to write x equals 2y minus 3. And we're now going to solve this for y. So what's the first thing you're going to do to both sides? Add 3 to both sides. You will get x plus 3 equals 2y. What's the last step? If you want y by itself, divide both sides by 2. Okay, so we found the inverse of h. Okay, I'll write that down here. Okay, h inverse of x, and I'm just writing the letter h because I think the original was called h, is this fraction right here. You know, you can write this slightly differently, so I may do that. H inverse of x is, now look, what's the number in front of this x? We don't really see it, but what is the number in front of this x? The coefficient is 1, right? So I can write it like this, okay? I'm going to write 1 over 2x plus 3 over 2. These are the same thing. they're equivalent, but I can't remember if ALEKS will ask you to write this in the slope-intercept form, but both should be accepted as correct answers, okay? But we found it. I'm going to copy this and put that as my answer here, okay? Now, let's do the very last one, okay? And the last one is super easy, okay? When they say to do a composition of a function with its inverse, okay? Because that's what's happening here, right? They're asking you to do, well, what they're doing is this first. Let me write this as h of h inverse of -7. That's what they're asking you to do, okay? So you plug in -7 into its inverse function first. After that, the answer that you get, you put it back in the original function, okay? Now, what's happening is, it's gonna, maybe I should, because we do have it, we can do it, but the shortcut is, let's talk about that. When you do a composition of a function with its inverse function, whatever that goes in will come straight out, okay? Because, you know, inverse functions are two different functions that undo each other, right? So whatever I did to -7, its effect got canceled out if I do plug it back into its inverse function. So that's going to be true for any function and its inverse. So I can ask you to do something like, what is h composed with h inverse of like anything, like any x? Guess what the answer will be? Just x. Because inverse and its original function, they undo each other. So whatever that went in as your original input will come straight out. So, and I didn't really want to do another composition of function all of a sudden, but if I use a little discrete example over here that we use, what if I ask you to do g composed with g inverse of, let's say, 7. See, what happened is I plug in 7 into the inverse function, and I will get a 9 out. But that 9 is now the new input of the original g of x. And guess what I get out when I plug in 9 into g of x? 7, right? So that works for every pair of a function and its inverse. Whenever you do a composition of a function with this inverse, the input will come straight out. So I didn't want to make it more complicated than what it really is. So that's something that you can use for your part C on this topic.